In this video, I'd like to illustrate the difference between the correlation between a pair of points and the slope of the best line through the data. This is sometimes a source of confusion for students, what the relationship is between the slope and the correlation. So here I've got some X data and some Y data. I've got two columns, about 200 observations of each, and here's a scatter plot of the data, and I've used Excel's Add Trend Line feature to draw the best line through the data. Excel also automatically gives me the equation for the line if I select that option in Add Trend Line. So for this particular set of points, we've got a best line through the data is y equals 2x plus 3. And we can also calculate the correlation between the x's and the y's. So right there in that cell, I've got the function Correl, and you can see that it's applied to the B range and the C range, the X and Y range. So that gives me a correlation of 0.8. And I've used the functions slope and intercept to give me the slope and intercept, which I can also just read off of there, slope of 2 and intercept of 3. All right, now in the spreadsheet, I actually have the ability to go in and change the data by controlling what I want the correlation to be. So these are my inputs. What really matters is the output. What does Excel say the correlations are? But I can vary the correlation. So let's suppose I decrease the correlation from 0.8 to 0.4, say. What happened? Well, notice that the slope of the line didn't change. It's still 2x plus 3, but they became much more spread out. That's the effect of lowering correlation. Let's undo that change. Let's go back to what we had before. And now let's try varying the slope. So let me increase the slope from 2. Let's make that 4, and you can see that the line got steeper, so now the slope is 4x plus 3, but the correlation hasn't changed. And I can see that the correlation hasn't changed. Again, what matters isn't what I think the correlation is, but what Excel says the correlation is. So there's the correlation function applied to the data, and indeed, it didn't change at 0.8. And I can make the line steeper still, and it gets steeper, but the correlation remains fixed. I can bring that back down to 2. And I can bring the correlation, if I bring it down to say 0.2, then the points get really spread out. They don't all fit on the chart. Now I can also try to put in a, say, a negative correlation of negative 0.8, but I get an error message because the slope and the correlation must have the same sign. So it doesn't make sense to talk about having a negative correlation when the best line through the data is a positive line. Let me change that so I will get a negative slope of 2. Now you can see I've got a negative slope, y equals minus 2x plus 3, and the correlation is minus 0.8. Again, I can make the slope steeper. That doesn't change the correlation. Or I can, let's say, make the correlation stronger. Let's make it, say, minus 0.95. If I do that, the points are very tightly clustered across about the line. So again, what this illustrates is that correlation can be strong or weak regardless of the slope. The slope just tells me the steepness of the best line through the data, and correlation tells me how close the points conform to that line.